In this video, I'm super excited to show you this RAG chatbot app that I created. This app actually only does one thing. It can answer questions about the rules of the game of Monopoly. But I'm really excited to show you how I built it because I think you'll learn a lot about RAG. But just to show you how it works, a user can ask any question about Monopoly. So for example, how do I start a game of Monopoly? And then click submit. It takes this question and it does a search against a Pinecone vector database where I've saved the rules of the game of Monopoly. And then based on the search results, it uses an LLM to summarize those rules and return them to a user. And also just for one more example, say you went to jail while you were playing the game. You could ask, how do I get out of jail? Click submit, and there you have it. Okay, so let's jump in and talk about how this was built. First of all, I used Pinecone as the vector database. I also used LightLLM to make the calls to the LLM models. I used Gradio for the front end, and I used python.env to do the authentication. I actually have other videos where I talk about LightLLM and Pinecone, and I also have a RAG concepts video where I go a little bit deeper into these subjects. So if you'd like a little more detail, please check those out. But even without watching those, I think you will be able to follow along and learn a lot from this video. To get started, we have to load our dependencies, and I already did the pip install to save some time. So let's go ahead and load our functions. If you've seen my other videos, you're probably familiar with this already, but we call this load.env function from python.env, and basically that saves out any API keys that we have in a .env file and saves them as environment variables that we can reference later. So what you would want to do if you're following along is you will need an LLM model. It does not have to be Anthropic, but in this video, it's Anthropic. So you would need to create an account at one of those model providers and then create an API key. And then of course, you will need to create a Pinecone account, and you can do that for free at app.pinecone.io. And then once you create your account, you can create an API key right here. And then once you have those API keys from both your model provider and from Pinecone, you will save them in a .env file. I'm showing you a .env demo file so that you don't see my actual API keys. And then you'll need to use these keywords for Pinecone and for Anthropic, and then save your API keys right here. And then when I run this, it's going to save those as environment variables, and we are also going to save the Pinecone API key right here in this variable. So then we'll initialize our Pinecone instance, and now we are able to use the Pinecone Python SDK through this PC object. Okay, so to continue along with our setup, we need to create a Pinecone index. We are going to give it a name called Monopoly Rules, and then you'll see a few different arguments here. We have to specify the cloud provider, the region, and the embedding model we want to use. For the free tier of Pinecone, we have to use this AWS, and we have to use US East 1. And then we can choose between a few different embedding models, but it really doesn't matter too much for this simple example. So we're going to stick with the default, which is Llama Text Embed v2. An embedding model is basically just a type of LLM that converts text into vector embeddings, or in other words, numerical representations of your text. And then this chunk text field will be used later when we are upserting data into our index. But first, let's create our index. And let's switch over to the UI and check that out real quick, see if it was created. I will be switching a little bit back and forth between the code and the UI, but technically once you create the API key, you don't need the UI anymore. You can just do everything through the Python SDK. All right, so it looks like it created our Monopoly Rules index, but we don't have any data in it yet, so that's what we need to do next. And what I've done is for the data that we will upsert, I've gone to the official rulebook of Monopoly and paraphrased the rules and converted them into a bunch of different chunks. I think there's like 70 different chunks. And then you'll see this chunk text field, and that's the one that we specified up here. That is the field that is actually going to get embedded or turned into a vector embedding. And then the other two fields, ID and category, are just additional metadata that we're not really going to use in this demo. So I will save those chunks as a list of JSON objects called Monopoly Rules chunks. So let's scroll all the way down. You can see all the different chunks we have. These are all just different rules of the game of Monopoly. And we will run this upsert records function to insert all those chunks into our index. Okay, let's go ahead and check out the UI, and I will hit refresh. All right, and we can see that all of those records were upserted. And just for fun, and I think this helps understand, if we go here and hit fetch, we can see that vector embedding value. This is just the first few of those comma separated numbers, but that's what it looks like when it gets turned into a vector embedding. All right, let's go back to the code. Right here, I'm just printing out some information about the index, but we already saw that information through the UI. So next, we're going to go over how to do a search against the index. Now, when we do a search against a vector database, it takes our question that we're asking, and first it has to convert the question into a vector embedding the same way it did with the chunks. Now, when using Pinecone, we can either let Pinecone automatically embed our question at the same time that it does the search, or we can manually embed our question first before we do the search against the index. And I'm going to show you both in this example. So this first one is where we just let Pinecone do the embedding at the same time it does a search. It's really straightforward. We just do index.search, ask our question. We're going to say what happens when a player is sent to jail. Give us the top 3 results or the closest matches from our vector database index. And we're going to save those in this results variable. And now that it's done the search, we will print those results. We are adding the score that was given, the category, and then obviously the text. So you can see that the text, these are all just the chunks. These are the top 3 chunks, the most relevant chunks from our search. We can see that they do indeed have something to do with what happens when you go to jail. And then for the second approach, it's not that much hard. It's just one extra step. You have to take your question, what happens when a player is sent to jail, and embed that as a vector embedding first. And it's really important to use the same embedding model that you use to upsert the chunks into your index. Otherwise, it won't work. And then you just do this inference.embed and save that out as a variable. And just for fun, we're going to print the first 5 values of that vector embedding, and just so we can see what that looks like visually. Okay, and then we do that search against our index down here. We plug in the embedding value. We do index.query this time instead of index.search. Save our results into a variable called results2, and you'll see it's the exact same chunks with the same scores. So we got the same result. One approach took one extra step, but I do like to show that extra step because it makes it more intuitive what's happening in the background when we do a search against a vector database. So once we have our relevant chunks from our search, we need to take those chunks and use them to help our LLM answer the question. And before we can do that, we want to convert those into like a nicely formatted context string. So this code right here converts the results from the first approach into a context string. And then this one is almost exactly the same, slightly different syntax. It converts the search results from our second approach. And then we printed it right here. And you can see that we've just taken the text from those chunks and we've saved it as this variable. So what we've done so far, right, just to recap, is we have created an index, added data to that index. We have run a search against that index, and we've saved the results of that search into a context string. Now, we just need to add that context string into our LLM call. So we go down here, and we are going to be using Claude Haiku 4.5 as our LLM, but you can use any LLM that you want. This completion method or function comes from LiteLLM. And the cool thing about LiteLLM is that no matter what model you're using, use the same syntax. Again, check out my video, it goes into more detail, but if you wanted to switch out the model, you don't have to change anything else besides this argument. Then in our system prompt, say use the following context to answer the user's question, and we feed it that context string. And then we have our question down here. What happens when a player is sent to jail? Now, you don't actually have to do that in the system prompt. That's one approach. You could also just shove this context string into this right here, and you could just get rid of the system prompt. It's up to you, whatever works best. So we're going to run that. And then when that's done running, now I will print the results. Okay, so now you see we have a nicely formatted answer. And again, just to recap, all that did is we asked the question to our LLM, and then we told the LLM to use the search results that we got in our earlier step to help answer the question. We're pretty much done. All we have to do now is turn everything that we've done into reusable functions that we can reference in our Gradio code so that we can use this logic in our app. So I have the code for each of the different approaches that we did. This first one is where we let Pinecone do the embedding of the prompt automatically at the same time it does a search. And I'm just going to skip over that one, but I wanted to leave it there for you just in case you want to use that one. All of this code, if I haven't said so already, is saved in my GitHub repository and is linked in the description. So we're going to skip over version 1 and look at this version 2. So you'll see that we have 2 different functions. One is this retrieve context function, which turns our prompt into a vector embedding, does the search against the vector database, and then saves the search results as a context string. And then we have this other function, retrieve and generate, which actually calls the retrieve context function. It calls it down here just to get the context string, and then plugs the context string into the LLM call. So it's almost identical to what I already showed you, but we're just saving these out in reusable functions, right? So I'm going to go ahead and save those functions. Just to show you what that looks like with the reusable functions is we have our prompt, what happens if I go to jail, we have our index, we have our embedding model, we have our inference model, and then we have the top K argument. And then we just plug those into this retrieve and generate function. And now it's running that RAG pipeline, and there's your results. So we've already seen that though, but the important part is that we're going to use that in this Gradio code to create a UI. This is also not a video about Gradio, so I'm not going to go into detail about Gradio. You can check out the code in my Git repo. But the important thing to understand is that we have this respond function that is just a wrapper around that retrieve and generate function that we just ran. And this function, this respond function, gets triggered when either we hit enter in our search box or when we hit the submit button. So we're basically just saying when we click the submit button, run the respond function up here, the input is going to come from this text box that we have where we type the question, and then the output is going to be saved as answer, which will be shown in this section right here. And then all you have to do is hit run. You can use the app here in VS Code, or you can open up the app in your browser, and there you have it. I hope that you learned a lot. I hope it was helpful. Let me know in the comments if you have any questions. But I hope that by walking you through how I created this app, you were able to learn a lot about RAG and really kind of get an intuitive understanding about how it all works. If this was helpful, please like the video and subscribe to my channel for more videos. Thank you.